The reason we're here is to enable your SOC, to talk about how maturity works when we're looking at a SOC, so talking about things like the SOC CMM model or other CIMM models, and the incident response model, which is something we use when we're talking to people about their maturity. We're also going to be looking at certain things like empowering your teams. So people like to throw around the phrase purple team quite a lot, or a red and blue team mixed together. I personally don't like the phrase, but it works quite well in this sort of organization. But we're talking about how we can enable our analysts through the time they're getting back. What does AI give us? Well, it gives us automation. It gives us time back in our day to actually do our job. And our job should be being analysts, looking at alerts as they come in, working out where the threats are, and hopefully cleaning them up and telling the CISOs what the hell the story is, because half the time they don't know from the outset. So it's about enabling the team through automation and doing that with AI. So obviously Vectra, we are a company that does AI, and we are a company that does automation as well, and we do integration. I'm not here to tell you just about our product, I'm here to talk about the wider view. When we're talking about maturity, so the SOC CMM is actually a really, really big Excel spreadsheet, the free version. You can do a paid version which is even bigger, but it asks you a whole bunch of questions about your security program, your processes, your people, your technology, but also the wider business as well. So how does the business work with your security program, and how do you feed into that part of the business? How do they interact with their services, etc.? It's a really comprehensive tool, and it gives you this great fancy spider diagram at the end which points to all different parts and says you could invest here, you could invest here, your process is great here. Fantastic tool. I recommend everyone looks at it for their overall maturity. The problem is the SOC CMM comes from a slightly older model, the CIMM model, the continuous improvement maturity model. Now, the continuous improvement maturity model is a really process-driven model. It looks at how do we define a process that makes something repeatable. You start off with initial, then you go to a repeatable process, then you go to a managed process, then you go to a predictive process, and then like a self-improving process. And there's this bit in the middle, this sort of feedback loop from predictive or defining process back to managed. And a lot of SOCs get caught in that loop. You get caught in the, let's say, 4 to 2. Because you get to a certain level and you're doing everything through logs, you're doing log managing, you're creating alerts, your analysts are there making sure all the alerts come in correctly, they're then writing rules which model behavior, and that feeds back into it being a managed service, and then they can do their job better, but 6 months down the line, they're doing it again and again and again, and your analysts become log farmers. They become people who are looking at things, trying to model behavior, and they're not looking at alerts, they're looking at your systems. They're feeding and watering, which is great if you want to learn how to feed and water log systems, and you can do that anywhere. So being a very process-driven model, it doesn't necessarily look at the nuance of what we want our analysts to be. So having a mature SOC doesn't necessarily mean having a multi-tiered SOC. You can be the best in class with 5 people. It might not sound doable to a lot of large organizations, but my previous SOC, there's a man at the back who can attest to this, was a team of 5 people. We were nationally recognized by a big circular building, and a building that sits on the Thames, as the best SOC they'd been into when they went in. We were 5 people. The reason we were classified as the best wasn't because we had really tight processes, really tight controls, because people still plugged in whatever they wanted. We had a really good way of taking that alert, actioning it, and then responding insanely fast. And we did this through automation. Automation of our reporting system, automation of our collaboration systems, and automation of other systems, bringing all of those alerts into one place. By having an alert that came in and said, we have a problem here, and then having our system in the background call APIs to pull in PCAPs, call APIs to pull in related events, call APIs to pull in logs from other systems which weren't necessarily available through the SIM, we were able to respond so much faster, and we had such a repeatable process because it was automated. 90% of the analyst's time was no longer spent making sure that we were modeling the correct behavior. It was spent looking at an alert and determining what the problem was. And because we were able to do that so fast, the rest of our time was spent on the internet. looking at memes and cats and doing research and reversing malware. So this incident response maturity model. So this is what I was driving towards. So this ranks people from 1 to 5. So this was actually a reaction to the CIMM models, the continuous improvement maturity models. And this was seen as a much more focused approach to how analysts and incident responders, which is ideally what you want your analysts to be, where they rank on the maturity. So we go from 1 to 5. 1 is incredibly reactive. You're super agile. These are the teams who've just been spun up. They get an alert from an antivirus system, they go and they get the machine, they turn it off, they take it back, they wipe it, they give it back, you're done. But it's not really a repeatable process because every time it comes in, they do exactly the same thing. But they're incredibly agile, they're super fast, but they're not necessarily aware of what's going on in the rest of the business. As you develop your security program, you tend to move to a level 3, which is a really process-driven security operations center. And what I mean by this is your security operations center are responsible for enforcing policy, writing policy, making sure that the policy is still fit for purpose. But when they're doing that, that's back into that feedback loop. That's that 90% of my time is spent making sure that my systems are working and they're adhering to policy, and you can't react like that, but you get a really good awareness of what's going on in the business because you have such a great touch point with the rest of the business. As you start doing things like automation of collection of events, these are through things like SOAR platforms, so things like the Hive project or Phantom and Demisto, you can start automating some of those response processes, collection of logs, collection of different data, and you start moving up into your intelligence-driven and your predictive defense. Now, for most people, being a 3 or a 4 isn't a bad thing. You know, you have a great process, you're sticking to it, and you're reasonably threat aware and you know what's going on in your business. But as you want to mature, you have to start looking at how to make your team more efficient. And intelligence-driven and predictive defense is really where a lot of people want to be. It's where a lot of people think they should be, but they're not entirely sure how to get there. So we use things like AI, automation, and response to enable this. So my old SOC, I said this previously, I spoke about them, recognized as best in class by acronym-named intelligence agencies in the UK. Built on the process of collaboration and automation. I can't stress that enough. We were a flat team. There were 5 people in a room. Everything we did had to be collaborative. We all had to be able to work on the events together. We had to talk. If we were in a tiered SOC, that necessarily wouldn't have happened. You know, handing tickets to people and saying, here's a ticket, please work on this. No, everyone spoke. Everyone was really rude to each other. We called each other terrible things. But then again, we were in the glass prison. No one else could hear us. And it was 5 men being very toxic in a very stinky room. I'm so glad I don't work there anymore for that reason. Like I say, flat structure of 5 people. Everything was built in-house. Now, I'm not saying you have to do this. This was about 3 years ago when we started automating. SOAR wasn't really a big thing then. You know, platforms like Phantom and Demisto weren't really mature. We did it ourselves. We rolled it ourselves. It became the way to do it. And we look at these platforms now and go, oh, well, we were already doing that. We were already collecting all these things. We're already starting with a single event and then pulling in all the information from the other products. I want to talk about the maturity. So a quick show of hands. Who in here thinks they are a tier 1, a reactive organization? So people get an alert, they immediately respond, but there's no process. Good. Oh, there's a couple of maybe sort of shuffling. Can I have my ball back, mister? Sort of hands in the back. Who reckons they're about a level 2? So halfway between process-driven and reactive? Excellent, excellent. A lot more hands, that's what we like to see. Level 3. So who thinks they have a lot of process? They're able to drive what they're doing through process? Middling? Middling. Level 4. Anyone think they are an intelligence-driven organization? And a level 5, a god tier, predictive defense. You are time travelers. You can tell me what the Hyodo network's going to send you next week. No? Okay, that's good. I haven't met many organizations that would call themselves level 5. Even though we were recognized previously as best in class, I wouldn't have called my previous position a level 5 either. I think we've had one of our customers says they're a level 5. I'll talk about them at the end. They're about a level 4 or 5, and that's 2 people. 2 people running a 20,000 person network. And they are incredibly good because they use automation, and network detection and response platforms to drive their process. So, on automation, what am I talking about when we're talking about automation? So where are our analysts spending their time? This is what I was talking about in that feedback loop. What we want people to be doing is focusing a lot of their time to reduce the dwell time of an attack. I think the dwell time's now come down so much that products have improved. We're no longer at 18 months, 9 months. We're down to about 6 months. Or if you are an Australian university, 19 years. This is a news article that broke this morning. There is an Australian university that has been implanted by Chinese APT for 19 years. So automation, it shouldn't be about replacing people. It should never be about replacing people. I say that we could do it with 5 people, 2 people. And I'm not going to say to any of you, get rid of your tiered SOCs. Tiered SOCs are rubbish. They're useless. We don't need them. No. There is value in having a tiered SOC. You need people who can do some basic triage. But what you also want to be doing is through automation and giving them time is enabling those people. Who here works in hiring of analysts? Does anyone get actively involved in the hiring of analysts problem? It's a really tough game. If you ever try to hire analysts, it's really hard because you have to go through so many people. And then after 6 months, when they've gotten everything they can from your organization and they've got a nice certificate, they will go and work for a vendor. That's what I did. I spent about 3 years at my previous position. I got to the top of where I could go, and I went to a vendor because they were exciting and I could see the future in this vendor. But now I'm hiring analysts again to be analysts in my company. And it's really hard. They will leave. So what you want to be doing is enabling those lower people that you have, the tier 1 analysts, to become your tier 2, your tier 3, your managers, your senior analysts. Because not only do they have a really ingrained depth of knowledge of your company, they're also going to be invested in your company because you've enabled them to be better. So by giving them time in the day for activities like research, for activities like reversing malware, if they've never done it, stick them with someone who's done it before. Or if they've never done it, just put them on a machine that's not on the network and let them go nuts. You give them time through automation to enable them to be better people, grow. There are times that you don't want to automate as well. And when I say times that you don't want to automate, you don't want to automate the final decision necessarily. Machines are really good at scoring between 0 and 1. And when I say 0 and 1, it's like a data science term, 0 being nothing, 1 being everything, and there's a gradient in between. Machines are really good at doing that. I mean, they've been doing that since, the 1940s, 1950s? If you look back at things like Bomber and the decryption of Enigma, this could almost be said this was an early concept of a neural network, of a perceptron. Those early, very simple networks that took a lot of inputs, made decisions, and then had an output. But it still needed somebody to look at that output and say, does this match up? Is this the correct decoding? Can someone make that final decision? Those more esoteric decisions have to be done by humans. And that's the last thing you want them to do. It's the human in the loop. You don't want to give all of the things over to automation because that's the way you will cut off all your network because something has said, this is really bad, let's just kill the network so that nothing bad else happens. Well, funnily, the bad thing happens is when the finance department rings you up and goes, why have all of our transactions stopped going through? And like I say, the best thing about automation is freeing up that analyst time. Let them do the interesting work. Let them reverse malware. Let them look at an attack campaign that they may not have had interest in. Ask them to do breach reports. In fact, towards the end of the slide, I've got some suggestions of things you can do to enable your purple team, to enable your analysts to become more attack practitioners so they know what they're looking for and they know what they're looking at when an attack comes in. Reducing attacker dwell time. This is where we want our analysts to be spending their time, turfing out the bad guys in your network. How many people have seen this diagram? This is the SOC triad of visibility. This is from Gartner. Anyone seen this one yet? Yeah, okay, seen this? You heard about this? So this is Gartner's way of saying the SIM is great. The SIM tells us so much about our network. It tells us logs, it tells us statistics, it gives us performance data. But to really get an understanding of what's happening on your network, you can't just rely on logs. We used to have a phrase in my old department, my old company, the logs don't lie. It's true, the logs don't lie. If they're there. If you have the logs, they tend not to lie to you. If someone turns off the agent, you can't install an agent because it's a Citrix environment that has a machine that pops up, and you can't put an agent on that because when it goes down, the agent's off and it comes back up, it has the wrong time. You can't install an agent there. How do you get those logs? You don't. You go to another part of the visibility triad. You go to network detection and response. You get a really broad view of the network. And then endpoint detection and response gives you a really close view of the individual hosts. And by having all of these things, you really can enable your visibility in the network to tell you where something's going wrong and pinpoint it exactly. Hunting requires specialization, the right data with the right context. So the SIM is a generalist. So for years, we've been sending everything to our SIM. And that's not to say that's a bad thing, but it's literally everything from routing, switching fabric, VPNs, servers, database errors, etc. It all gets fed into a collector, which then gets normalized. You have to normalize the behavior into regular timestamps if you're bringing in from all over the place. It then gets indexed and databased, and then finally it's turned into analytics and reporting. But it's such a general tool. You can get anything from it, but the biggest problem is you can get anything from it. Problem of this is you get the sort of least common denominator problem. How many people have done this maths homework where you have to find the least common denominator? It brings back so many bad memories at school of writing tables of numbers. You're trying to look for the least common denominator in a lake of data, or a data lake. So what is the least common denominator trap for these generalists? Well, by feeding everything in to your SIM, or your network traffic collection, what you end up with is, to find network data, you end up with something that's a bit like NetFlow. How many people use NetFlow in their organizations for security? A little bit, yeah. I've used it. It's really good for telling me where things are coming from and how much was sent, but it's about it. You know, it's like reading a book, but you don't read the book, you read the chapter headers. You go, what happened in this chapter? Cool. What happened in this chapter? Cool. What happened in this chapter? That's War and Peace. I don't know what the problem is. That's a really short book. You have no idea what's going on. There's no nuance. Least common denominator. By having all of these, you end up with something like NetFlow or the least common denominator. So how do we get the right data to reduce the attacker dwell time? Well, we ask the right questions. If we needed to identify something like a hidden tunnel or remote access tool or data movement inside our network, we need to know more about that network data than just the headers. We need to know the shape of the data. We need to know timing data. We need to know the shape of the data whilst the flow is still active. So we require something like this, intermittent session. So this is a Vectra slide. This is one of our proprietary tools, intermittent session, iSession. It contains all of that data, and it's allowed us, as an automation company, as an AI company, to make decisions about flows as they're happening, to make detailed analysis of flows in flight, and to say, this looks like a tunnel because we have all of this timing data. And this isn't done through NetFlow collection. This is done through raw packet analysis, so getting a feed from a switch. This is how we do a lot of what we do, is with this timing session, the sub-second timing, the shaping information. And that enables us to find things like hidden tunnels, rats, internal data movement, people gathering data inside your network and then slowly exfiltrating out somewhere else that you didn't expect, smuggling that data out of the network, not just zipping everything up and chucking it out the door, because no one does that anymore. This isn't APT1 days. People are really sneaky now. They get things done really slowly. So the right context gives you something to hone in on. So this is the Google backstory. But Google backstory is their SIM. This is their log collection. This noise at the bottom are the really common events, and then the ones that have surfaced to the top are the uncommon events. But those uncommon events kind of have to be dictated by you, because otherwise you would get loads of really uncommon events just surfacing at the top. You'd have no idea where to start. There's just, this one log has appeared because somebody used a service account in the wrong way. And you go, well, that's something to look into. You go, yeah, but you've also got these 17 other competing things that have gone wrong very sporadically on different systems. There's so much to look into. There's too much data. So maybe the right context is to look really close. So this is a screenshot from Crowdstrike. Maybe we need to know exactly what's happening. So as opposed to saying something weird has happened, go investigate, we need to see as much as possible. Something weird has happened. It turned out a process was started on a machine. Well, what was that process? Well, it was PowerShell. Well, what was the command path? What was the execution path to get to PowerShell? What happened after PowerShell? What are my outbound network resources? So we have the generalist view and the specialist view. The generalist view is really interesting. You get a whole bunch of data types. but it's not really optimal for many people. You know, looking at all of these logs isn't necessarily optimal for a team of 2 people, 3 people. And that may be where a lot of people are with the problem of hiring analysts. Having a really specialist view is great for those teams which have time to investigate the specialist things. They get an endpoint defense response alert, and they say, well, now I need to go dig into that, and then they dig for hours and hours and hours through the dirt. Go, oh, it was normal. How could you define if that was normal or not unless you had a really wide view as well? So this is what we do. Just going to skip over this because I'm going to tell you about what we do. More about sort of network defense and response. Everything through AI. Cognito Detect is our core product. Recall and Stream are like the metadata. So Detect will tell you there is a problem, and here's a load of data. And if you want to see all of the other data, the metadata that exists, we either pump that out to the cloud using Recall, or we can do that on premises with Stream. So the idea is to marry network defense and response with endpoint defense and response. It's a really broad view of what's going on with analytics and AI to enable the detection of things like hidden tunnels, rats, internal movement, lateral movement, reconnaissance, and marrying that with endpoint defense and response to say what actually happened on that host. A lot of people have complicated networks. There's lots of different devices. We have computers, we have laptops, mobile devices. We have a drone for some reason, and a robot arm, and some streetlights. Whoever owns this network has got a lot of OT. It's great, I love it. I want to look at this network. But then we've got our servers, we've got routers, we've got switches. Not everything can have an endpoint on, right? So we can get endpoint on a few of these things, but for a lot of these things and a lot of the other communications, we can't get an endpoint. What we have to do is look at the broad view, look at the network view. So we take radically different approaches that are highly specialized. So where the SIM is a generalist, as a network defense and response platform, we want to be specialists. We want to look at what on the network is giving away that there is a compromise. What attacker behavior is there? We're not just looking for anomalies. You know, we don't just want to say this user has logged on from Tahiti because he's on holiday. That's weird. No, that happens all the time. But the user has logged on and now they're touching services they've never touched before. They're using an admin account, which we've never seen them use before, and now they're using a service account. This is starting to look bad. This host needs to be flagged. At which point your network defense, your endpoint defense and response can drill into it and go, right, what's actually happening on that machine from a process level? So by having just those 2 products, endpoint defense and response, network defense and response, we can actually drive very quickly into an answer. Because the network defense and response is automated and said, here is the behavior that's strange, here's the behavior that's malicious, and then the endpoint has said, here are the actual processes. So our analysts have spent very little time. They haven't had to look through the logs to find all the weird behavior from that machine. It's been automated. And diving into the host has also been automated because all of that's already done through the endpoint agent. We have information about the process. We have information about the network resources. We can see where this is communicating, and we can even take a reaction on that as well. We can stop that host communicating. We can lock it down. We could leave it there and see what else it does and see where it pokes, and maybe we can do some attribution. I wouldn't recommend it. Turn it off. Do your forensics later when you're not losing data. That rhymed. So we take a really similar approach to endpoint defense and response. We want to be specialists. And that's what we want our SOC to be as well. We want them to be specialists, not generalists, not feeding and watering a SIM, not working out what logs I need to surface to enable me to find this attack. We want them to be threat hunting specialists, incident responders. We want them to know how to attack a platform as well as defend it. There we go. Analytics focus. We want people, this is where we do our analytics. So from files and processes, or network behavior, community of devices and accounts. We gave this talk at our customer summit not too long ago. And this is part of how we explain this in real world terms. So endpoint defense and response, network defense and response. It's like hunting submarines. It actually came from what can the Titanic teach us about cybersecurity? Well, everyone knows Titanic hit a whacking great iceberg, sunk. They said, how do we find icebergs? Put a big sensor on the front, the Fessenden oscillator. Find massive icebergs. Then World War I kicks off, and in the Firth of Forth, first torpedoed ship goes down. How do we find submarines? Put the Fessenden oscillator in. It'll find icebergs, it'll find submarines. Strangely enough, it didn't. Submarines are tiny compared to an iceberg. Icebergs are huge. So after the First World War, they had to come up with all sorts of techniques to find these small, agile things, these submarines. So they came up with not just one solution, not just two solutions, a whole net of solutions. So now we have active sonar, passive sonar, things like ESM, and we enable it across multiple things. So we have ships that are using things like radar and active sonar to look for submarines in the water. We have planes and helicopters using things like dipping sonar to give us a really big view of the combat, of the area of operation. A bit like network defense and response, looking at the entire view. At which point, using things like sonar buoys, using things like dipping sonar, we can say, we think a submarine is here. We think there is something here. Could be a submarine, could be a blue whale, but something is there. At which point, the submarine uses something like ESM, or it can look for the acoustics of the device and say, right, we know from the acoustics and the patterns we've seen before, much like your endpoint, that this is this type of submarine, this classification, because we can see the bow wave, we can see the electric signature coming off it. That's like your endpoint defense and response. That is looking very general, very specialist and saying, we can match it to this because we have such a close-in view. And by matching the two, that's how sub-hunting is done. And that's kind of what we're trying to replicate in the security industry. We're looking at the big view to say a problem is on this host, and then we're using specialist tools to drive in and say, and this is why it's a problem. This is exactly what's going on. So, hunting via EDR, endpoint defense and response, you're looking for processes that start and actions on the endpoint. You can look at this across your endpoint estate and have an idea that things are happening across your endpoint estate. Maybe give you an idea of what's happening on your Windows, maybe on your servers, Mac, etc. Plus the network defense and response. So looking for patterns of communication between those devices, maybe those devices which don't have endpoints, or have the endpoint switched off because you couldn't install an update and nobody forgot to turn them back on. Putting them together equals EDR and NDR. The hunt for following the bouncing ball, trying to find the problem using automation of hunting on the network, things which can surface anomalies, and the automation of the response when you get to an endpoint, integrating your EDR with your NDR to make you as efficient as possible, make your analysts as efficient as possible. So initiating an investigation. So we have an EDR alert, an NDR alert, a known C2 alert, a sandbox alert, all these different alerts. Well, a good analyst will start by asking the right question. What does the alert claim? Well, what am I looking at? What is the alert telling me? What is known about the origin or destination? How did this get into my enterprise? And where's it going out to? What's it exfilling? What's it C2ing to? What is known about the software which performed the action that triggered the alert? This is telling the story to your CISO. As an analyst, this is what you want to do. Developing your team. So some quick ideas for things you can do with all of your extra time. Things you can do. This is about developing your purple team. What you can do with your extra time, how to make your people practitioners. We talk about storyboards, attack playbooks, live fire exercises, virtual simulation, and tabletop exercises. So storyboards are really good. These are built from public breach reports, internal breach reports. Who here keeps their internal breach reports? I don't. One person does. Yeah, no one keeps internal breach reports, but you should. If you have a compromise, you should write it up afterwards. Write the timeline. Try and make it like one of those white papers that you see on the internet. From these, you can build storyboards of what you should find. And you can look at your tooling and say, where would I find this attack? So look at something like Lokagoga. Look at something like NotPetya. Say, right, if this was in my organization, how would I find it? How would my analysts go about finding it? Let them build it. Because by doing that, they know where to look. This builds muscle memory. How do I respond to this? Attack playbooks. So attack playbooks are used to identify the way that attackers move throughout your network. There's a big problem in security at the moment. Defenders tend to think in lists. I have an alert, I do my response, I get this log, I tell you what it is. But attackers think in graphs. I'm on a network. What are my options? Well, I have all of these options. Where can I go from here? Where can I go from here? By writing attack playbooks and letting your analyst team do this, thinking about your network, your environment, they will look at the network and say, how would I move throughout this network? Which is going to then teach them, where do I need to look to find someone who is moving through this network if they had no information? These have to be agnostic as well. You can't say to a team, write me an attack playbook, and they go, well, I know everything that's compromised already, so I would do it like this. No, come at it with no information. You have no guilty knowledge. Write it from the start. How would I attack my network if I were an outsider? If I landed on a machine, what would I look for? And I didn't land on the domain admin's machine. I landed on Jeff from HR because Jeff wanted free cheese and there was a link in an email that gave him free cheese. That's where you land. Then you do your analysis. That's where you analyze the network, work out where you're going. So attack playbooks not only tell you what you would do, but they also give you a great place to where you would look. Live fire exercises, running red teams. So analysts can train on your own network. If you have somebody who comes in and compromises your network for you, we're talking about sanctioned compromises. I don't want people just to think they can go away and open documents and go, we will then let our analysts fix the problem. Don't do that, it's a terrible idea. Get someone in to actually analyze your network. Run a simulated attack. There are differences in red teams. Some red teams are like checkbox exercises. I found this vulnerability, I found this vulnerability, I could have done this. Get someone who will actually test your network, who will compromise a host, move laterally, maybe install an implant, and let your analysts try and find them. And it's really important that everyone documents everything. I can't stress this enough, because when you have a wash-up meeting afterwards, you really want your red team to be able to say, at this time we did this, at this time we did this, and for your blue team to say, this is how we caught them. This builds training scars, this builds memory for people when they get compromised and they don't want to look like idiots in front of the red team when it comes to the wash-up meeting. They're going to try their hardest to repel the red team. And afterwards, when a real attack comes in, they're going to remember that feeling of, I don't want to get caught out, and they're going to be much faster, much better at responding. Virtual simulations. So virtual simulations are a great way to do this as a blue team. So you can build an environment. We actually have an open source environment we can talk to you about if you come and see us at the booth outside called VMAL. It's the Vectra Mobile Attack Lab. It's a bunch of images. The only thing it doesn't come with are the Windows licenses, but it builds a virtual environment like this with a router, an external side, an internal side, as DMZ, a bunch of hosts, a bunch of servers, and the first step from the attacker perspective is compromising the systems. There's no cheats, there's no, you already have an implant, you have to deliver an implant into the system. You can do it through a vulnerability, you could pretend to have spearphished someone and install an implant, but you have to control it from the outside. And then from there, you could actually start compromising whatever you like, start doing what you like, moving around it laterally, and seeing how it feeds into your tools using PCAP, because that is available in this one. You can build it yourself. If you let your analysts do this, then they're going to get a greater understanding of what it's like to be an attacker, to be on the bad guy side and say, well, I don't know what I'm looking at. What tool marks are left when I do an MBT scan? What tool marks are left when I do an SMB account scan? You know, really building that muscle memory of being an attacker and thinking like an attacker as well. These are great tools for low-level analysts as well. Just make sure they're shadowed by a higher-level analyst who can sort of guide them a little bit in what they're doing. When I started my career as an analyst, I wish I'd had something like this so I could just go nuts and destroy a system that we could then just rebuild and see what it did. It took me a lot longer to find that sort of environment. Tabletop exercises. This is kind of an interesting one. Tabletop exercises are usually done by very high-level management for disaster recovery plans. Things like the data center has been flooded. How does our disaster recovery plan enable us to bring the data center back or bring our data back? Tabletop exercises can actually be really useful for your SOC as well. By using things like the storyboards, you can write a playbook and say, this is what an attacker did, and then put a scenario in front of your team and say, we have an alert from a system, this is the alert, go and query some information. And they can ask questions, they can ask you questions, say, well, what do we get from NDR? What do we get from EDR? What do we get from the firewall logs? What do we get from this? And you can feed them back information, a bit like being a dungeon master. Or they can just do this themselves and work out where they would look, what they would uncover. And at the end, you can say, well, this was the attack, this was the storyboard, this is the playbook. These are really useful things for our analysts. We've run these with our customers in the past, and they've been really successful. People really enjoy them, they're really engaged, and it really helps people think. Even if they're not an analyst, helps them think like an analyst as well and get embedded with the people who do think like this. So a few closing thoughts, but let's close out. So, quick mention about that company with 2 people. They started off their journey about 7 or 8 months ago. They were very process-driven. Somebody said, build a program to one guy, and he went out and looked at a whole bunch of tools. And he looked at some crazy amount of tools. He came back with 2. That was Vectra, us out there, and Crowdstrike, EDR. Using the 2 together, they managed to automate a lot of tasks. They managed to automate their response process. So now they can respond to something in a matter of an hour when an alert comes in. They get an alert from Network Defense and Response, from Vectra Cognito. They dive into Crowdstrike to see if it's a problem. And they've actually saved a significant amount of money for their company, 2 people. A lot of people say they find it difficult to get budget for their SOC. these guys have had no problems. Not because they've been compromised a bunch of times, but because their company did some mathematics and said, oh yeah, you've saved us a lot of money just by responding to these security events. If we'd been breached, it would have cost us so much more. Here's some more money, make yourselves better, hire another person, let's get even better. They've come from a very low level up to a 4 or 5. Important lessons for threat hunting. What a tool was built for matters. Effective hunting requires the right data with the right context, so making sure we see everything, network defense and response and endpoint. And defense in depth is best realized when the vantage points are radically different. This is our visibility. If you want to find out more, we have some resources on our website, vectra.ai/resources. Thank you very much.